In this video, we're going to look at how to graph the cosecant function and the secant function. So first, let's look at the cosecant. So if you recall, the cosecant is the reciprocal of the sine function. So first, we're going to sketch a graph of the sine function and then use the values of the sine function to graph the cosecant by taking their reciprocal. So we know that the sine function starts at an x-intercept, and at all of the at pi over 2, we have a maximum value. At pi, we have an x-intercept. At 3 pi over 2, we hit a minimum value. And then at 2 pi, we have an x-intercept. And the sine function is here. And that is the sine function. So now we're going to use this to graph the cosecant function. And we're going to just take the reciprocal of these values here. So when theta is 0 for the sine function, its reciprocal is going to be undefined. 0 over 1, take its reciprocal, we get 1 over 0. So we're going to get a vertical asymptote at every x-intercept. So all of our x-intercepts become vertical asymptotes for our cosecant function. So we're going to have a vertical asymptote at 0, at pi, and then also at 2 pi. Okay. Then at pi over 2, we have a value of 1. So if we take the reciprocal of 1, it's still 1. So this point is on both the sine and cosecant curve. If you take a look at here at pi over 6, we know that pi over 6, the value is 1/2. So if you take the reciprocal of that, you're going to get 2. So at pi over 6, the cosecant is going to be 2. And then at 5 pi over 6, it's also going to be 2. So our graph is going to be opening up for the cosecant. So it's going to have 1 here, and then it's going to open up and out like this towards these vertical asymptotes. And then when you're taking the reciprocal of -1 down here, it's still going to be -1. And then it's just going to do the opposite. It's going to open in the opposite direction since we're taking the reciprocal of these values. So it's going to open down like this on the second half of our function. So the graph in purple is the cosecant function. So the graph in purple is our cosecant function. So the period for the cosecant function is the same as the sine, and all the transformations that happen to the cosecant function first get applied to the sine, and then you just graph your cosecant after that. We're going to do something very similar for the secant function. First, we're going to graph the cosine and then use its values to graph the secant. So the cosine starts at its maximum. At pi over 2, we hit an x-intercept. Pi, we have a minimum value, back to an x-intercept, and then at 2 pi we have a maximum, and that's the one cycle of the cosine function. So there's our cosine function. Let me clean it up a little bit here. And then just like we did with the sine function, anywhere that there were, with the cosecant function, anywhere there are x-intercepts, those are going to become vertical asymptotes because the reciprocal of 0 is undefined. So vertical asymptote at pi over 2 and also at 3 pi over 2. And then again, anywhere that there was the maximum in our function is going to be included as well, right? Because the reciprocal of 1 is 1, and it's going to open up in the opposite direction, have the opposite concavity of that part of your function. So this is going to be concave down like this. And then this is going to be concave up like this. Now, these also would continue to go like this in that direction, but we're just graphing one cycle. So it's going from 0 to 2 pi. Again, just like the period of cosine, the period of secant is the same. And then the transformations that get applied to the cosine are then translated into our secant function. So when we're looking at the general forms for these, the value of A affects the sine or cosine graph, right? It changes its amplitude, and then it will kind of affect where the minimum and maximum portions are for our cosecant and secant function. And then we still find the period by taking 2 pi divided by omega, and then B just represents the vertical shift, and it changes the midline.